Hello everyone, welcome back to my channel. I hope you are all having a wonderful day. Today we're going to talk about how to implement AAB collision in SFML. By the way, this works in any library or any language as long as you get the math. It's pretty simple, it's just a bunch of inequalities, so basic algebra. As we can see, we have two inequalities for each axis. So in total we have four inequalities. Let's first review the first one. If rectangles 1 left is less than this basically means the rectangle's to right, because if you're in left, then you add the width, you're essentially going to the right side. So if the left of rectangles 1 is less than the right side of rectangle 2, let's see, rectangles 2 rectangles 1 left side is less than rectangles 2 right side, so that inequality is true. Now let's go here. Another inequality, this is the second one. Rectangles 1 left side plus width, so we know that's the right side. If the right side is greater than the left side, let's check again. Right side is greater than the left side. That means there's an intersection at the x-axis. So now x overlap is true. Let's check for y overlap. Here is where it essentially gets tricky, but it's not hard. It's because in graphics programming, the y-axis is inverted, but the math is essentially the same. Okay, let's start with the first inequality. If rectangles 1's top, this is the less sign, but let's remember it's inverted, so this is essentially a greater sign. So if the top of rectangles 1 is greater than the bottom, as I said, it's inverted, so this is like a minus. Let's check here. If the top side is greater than the bottom, then this is true. Let's check for another inequality. If the bottom of rectangle 1, if the bottom is less than rectangles 2 top, then that is a collision. So let's check. Bottom of rectangle 1 is less than top. Bottom is less than the top. So there is a collision in the x-axis. Now, if we combine both of these, that means there's an intersection 100%, not just on one of the axes, there's an intersection in both axes. As we can see here in the function, we return. We return if this is true and this is true. Then we made a variable to get input from the function. And we just change the colors or just output in the terminal if it's a collision or not. So let's run this program. All right. As you can see, there is no collision because we're not outputting anything. So let's move it. Collision detected. Now let's try from this here, from this. As you can see, this is collision detected also. Alright, thank you for watching, and make sure to subscribe and like in the code, and I will put the code in the description.